Hi Tyler. We reviewed, cleaned, and analyzed the data you sent over. I'll quickly go over the changes that we made to the data. First off, a few students left their entries entirely blank. We removed these students' entries from the data. In addition, there were a few students who left their entries partially blank. We decided that the accuracy of these entries was questionable, so we've also removed these students' data from the rest of the data. Finally, a few of the students entered data differently than the rest of the students. We've gone through and changed these students' data to conform with the standards that the other students set.
In order to come up with a regression model, first scatter plots of each predictor versus MPG were made in order to determine if data needed to be transformed. We noticed that if we take the natural log of the engine displacement data, it becomes more linear, so we replaced the engine displacement data with the natural log of that data. Using this data, we created a best subsets regression and decided to start with the 6-var model with an adjusted RSQ value of 68.9 and a Mallows CP of 4.9. To further tune the model, we examined the p-values of each predictor in the model. We found that the length predictor was the only one with a p-value greater than 0.05. However, since its value 0.053 was close enough to 0.05 to keep in, we decided to test both this 6-var model and the 5-var model, excluding the length as they are equally viable options.
The 5-variable model had the second lowest Mallows value behind the 6-variable model and produced an adjusted R-squared value of 68.41, whereas the 6-variable model produced an R-squared value of 68.63, so they were very similar. We decided that the 5-variable model would be favorable for minimizing computational and operational costs, but the 6-variable model would be better for prediction accuracy due to its low Mallows and adjusted R-squared values. Therefore, we decided to go with the 6-variable model containing year, weight, percentage of weight at the front, length, cylinders, and the natural log of the engine displacement as our regression model.
Hello, Mr. Shada. We constructed prediction intervals for small, 2,000 pounds, mid-size, 3,000 pounds, and full-size, 4,000 pounds cars. For the other factors in the regression model, we picked the average value for each of the 6 variables: year, percent of weight at the front, length, cylinders, and the natural log of engine displacement.
We picked the average for each of these values in order to simulate the most typical value for that car size. We ran the test with those values and found that the prediction value for the small car was between 1.66 and 18.79. The prediction for the middle-sized car was between negative 11.129 and 7.155. The prediction value for the full-size car was between 10.275 and 25.886.